From where we stand here on the surface, the Earth feels incredibly large, almost beyond imagination. The land stretches out in all directions, with continents spreading across vast distances that reach into many thousands of miles. The oceans, deep and wide, cover most of the planet, taking up a little more than 70% of everything we see on the surface. Rising high above all of this is Mount Everest, reaching nearly 30,000 feet into the sky, standing as a powerful reminder of how tall and impressive features on Earth can be. For the earliest humans, Earth was not just a place to live, it was everything that existed. There was no idea of planets, stars, or galaxies as we understand them today. The sky above them looked like a giant curved ceiling, almost like a dome, with small lights shining on it at night. These lights were the stars, but to them, they were simply distant points with no clear explanation. The ground beneath their feet seemed flat and endless, stretching out forever in every direction. This belief was not foolish. It came directly from what they could see with their own eyes. When you stand on flat land and look far into the distance, the horizon appears straight and level. The curve of the Earth is so gentle and so wide that it is impossible to notice unless you travel very high above the surface. As people learned more, they began to measure the Earth. They discovered that the distance across it, going through the middle at the widest part near the equator, is about 7,926 miles. That number alone is difficult to imagine, but it becomes clearer when you think about traveling around it. If it was somehow possible to walk all the way around the Earth along the equator, even across the oceans, you would cover about 25,000 miles. If you walked at a steady speed of 3 miles per hour and you kept going for 8 hours every single day without fail, it would take you about 3 years and 1 month to complete the journey. That is a long, demanding walk, one that shows just how large the Earth feels from a human point of view. The total surface of the Earth is also enormous. It covers about 197 million square miles. To understand how big that is, imagine trying to visit every single square mile on the planet. If you spent just 1 second in each place, moving constantly without rest, it would take more than 6 years to cover it all. Even the largest countries only take up a small part of this total. For example, the United States covers about 3,800,000 square miles, which is less than 2% of the Earth's entire surface. This shows that even something we consider very large is only a small part of the whole planet. However, this sense of size begins to change the moment we start looking beyond Earth. When we slowly move outward and compare our planet to other objects in space, Earth does not physically shrink, but it begins to feel less central and less dominant. It changes from being everything to being just one object among many. As we continue to look farther and farther away, it becomes smaller in importance and harder to notice until it is almost impossible to see at all. The first place we reach when we look outward is the Moon, our closest neighbor in space. The Moon travels around the Earth at an average distance of about 238,855 miles. That distance is equal to driving around the Earth's equator about 9.5 times. By human standards, this is an enormous gap. When astronauts traveled to the Moon during the missions of Apollo 11 moon landing and other Apollo journeys, it took them about 3 days to make the trip. The Moon itself is smaller than Earth, but not by an extreme amount. It has a diameter of about 2,159 miles, which is a little more than 1/4 of Earth's diameter. This means that while it is clearly smaller, it is still quite large when compared to most moons in the solar system. If you imagine Earth as a basketball, the Moon would be about the size of a tennis ball. That comparison helps make the difference easier to picture. What surprises many people is not just the size of the Moon, but the space between it and Earth. The distance separating the two is about 30 times the diameter of Earth. In other words, you could line up 30 Earths side by side in the gap between our planet and the Moon. This reveals something very important about space. Even between objects that seem close to each other, there is a huge amount of empty space. Pictures often show the Earth and Moon looking close together, but in reality, they are separated by a vast stretch of nothing. The relationship between Earth and the Moon is also unusual. In many other cases across the solar system, moons are very small compared to the planets they orbit. But our Moon is relatively large when compared to Earth. Because of this, some scientists even describe the Earth and Moon as a pair that behaves almost like a double planet system. The Moon is not just a distant object in the sky. It has real and important effects on our world. It is responsible for the tides in our oceans, causing the water to rise and fall each day. It also helps keep Earth's tilt stable. Without the Moon, the angle of Earth might shift more dramatically over time, leading to strong and unpredictable changes in climate that could make life much more difficult. When we look at the Moon from Earth, it appears to be about the same size as the Sun in the sky. This might seem strange, but it is simply a coincidence. The Sun is about 400 times larger than the Moon, but it is also about 400 times farther away. Because of this balance, the Moon can sometimes pass directly in front of the Sun and block it completely, creating a total solar eclipse. The Moon is not staying in the same position forever. Each year, it slowly moves farther away from Earth by about 1.5 inches. This movement happens because of the way Earth and the Moon interact through gravity and tides. If we go back billions of years, the Moon was much closer to Earth, and the length of a day on Earth was much shorter, possibly only about 5 hours. Over time, the system has changed to what we experience now. In the year 1969, humans achieved something that once seemed impossible when they first walked on the surface of the Moon. This moment showed how far human curiosity and effort can go when we choose to explore beyond our limits. Beyond the Moon lies the Sun, the source of light and energy that makes life on Earth possible. Without it, our planet would be cold and lifeless. But when we compare Earth to the Sun, the difference in size becomes almost overwhelming. The Sun has a diameter of about 864,000 miles, making it more than 100 times wider than Earth. Its size is so great that about 1,300,000 Earths could fit inside it. Everything that has ever existed on Earth, every mountain, every ocean, every living being, and every moment in human history has taken place on a planet that is only a tiny fraction of the Sun's size. In fact, the Sun contains almost all the mass in the entire solar system, about 99.86%. All the planets, moons, asteroids, and comets together make up only a very small remainder. The distance between Earth and the Sun is also vast. It is about 93 million miles. This distance is so important that it has its own name, called an astronomical unit. Light from the Sun, traveling at an incredible speed, takes about 8 minutes and 20 seconds to reach Earth. This means that when we look at the Sun, we are actually seeing it as it was a little more than 8 minutes ago. If the Sun were to suddenly disappear, we would not know right away. It would take those same 8 minutes and 20 seconds before the change became visible to us. To understand how far away the Sun is, imagine traveling that distance by car at normal highway speeds. It would take about 176 years to complete the journey. Even the fastest spacecraft ever built, the Parker Solar Probe, which can reach speeds of more than 400,000 miles per hour, still takes months to approach the Sun. The Sun may seem special to us, but in the vast collection of stars spread across the universe, it is actually quite ordinary. Astronomers place it in a group known as G-type main sequence stars, often called yellow dwarfs. This simply means it is a stable, middle-sized star that shines steadily by burning its fuel deep inside. It is not one of the largest stars, nor is it among the smallest. It sits comfortably in the middle, doing its work quietly but powerfully. The Sun has been shining for about 4,600,000,000 years. That is an incredibly long time, far beyond anything in human history. In the life of a star, however, this age places it somewhere in the middle of its lifetime. It is neither young nor old. It still has a vast supply of fuel left, enough to continue shining for roughly another 5 billion years before it begins to change and slowly approaches the end of its life. Inside the Sun, an extraordinary process is taking place every moment. Deep in its core, where the temperature and pressure are unimaginably high, hydrogen atoms are constantly being squeezed together and transformed into helium. This process is known as nuclear fusion, and it is the reason the Sun shines. Every second, the Sun converts about 600 million tons of hydrogen to helium. This is not a small or gentle change. It releases an enormous amount of energy, far beyond anything humans have ever been able to produce. To truly understand how powerful this is, imagine all the energy that human civilization has created throughout its entire history, from the first fire ever lit to the most advanced machines of today. The Sun produces more energy in just 1 second than all of that combined. It is constantly pouring out light and heat in every direction, filling space with energy that travels across millions of miles to reach Earth. The surface of the Sun is incredibly hot, reaching temperatures of about 10,000 degrees Fahrenheit. Even at this level, it is far hotter than anything naturally found on Earth. But this is only the outer layer. At the very center of the Sun, where fusion happens, the temperature rises to about 27 million degrees Fahrenheit. The pressure in this region is also extreme, about 260 billion times greater than the air pressure we feel on Earth. Under these conditions, matter behaves in ways that are difficult to imagine, and it is this intense environment that keeps the Sun alive and shining. The Sun is not always calm and steady. From time to time, it releases sudden bursts of energy known as solar flares, along with massive clouds of charged particles called coronal mass ejections. These events send energy and matter rushing out into space. When they are directed toward Earth, they can create beautiful displays of light in the sky near the polar regions, known as auroras. These glowing curtains of color are one of the most stunning natural sights on our planet. However, these solar outbursts can also cause problems. They can interfere with satellites orbiting Earth, disrupt power systems, and affect communication networks that people depend on every day. Looking at the Sun also teaches an important lesson about our place in the universe. For a very long time, people believed that Earth was at the center of everything, with the Sun, the Moon, and the stars all moving around it. This idea felt natural because, from our point of view, everything in the sky seems to circle around us. But this belief was eventually challenged by thinkers like Nicholas Copernicus and Galileo Galilei. They showed that it is actually the Sun that sits at the center of our solar system, and Earth is just one of several planets that move around it. This discovery changed the way humans understood the universe and marked an important step toward realizing that we are only a small part of something much larger. When we begin to look beyond Earth, the scale of our solar system becomes clearer. The region closest to the Sun is known as the inner solar system, and it is home to 4 rocky planets. The closest of these is Mercury, a small world that experiences extreme conditions, with intense heat when it faces the sun and deep cold when it turns away. Next comes Venus, covered in thick clouds of toxic gases that trap heat and make it one of the hottest places in the solar system. Then there is Earth, the only known planet with large amounts of liquid water on its surface and conditions that support life. Its distance from the sun is just right, allowing temperatures that make oceans, rivers, and weather possible. Beyond Earth lies Mars, a cold and dry planet that shows signs of having once had flowing water long ago. These 4 planets are often called terrestrial planets because they have solid, rocky surfaces. All of these inner planets stay relatively close to the Sun. Even the farthest of them orbits within about 1.5 times the distance between Earth and the Sun. Compared to the vast distances found in the outer parts of the solar system, this region is quite compact. Yet even within this smaller space, there is an incredible variety of worlds, each with its own story, its own conditions, and its own place in the grand structure that surrounds our star. Between the orbits of Mars and Jupiter, there is a wide and mostly empty region known as the asteroid belt. This part of the solar system is filled with countless pieces of rock, ranging from tiny dust-like grains to much larger chunks. These rocky bodies are often described as the leftover building materials from the early days of the solar system, fragments that never managed to come together to form a full planet. Even the largest among them stretches only about 580 miles across, which is quite small compared to the size of Earth. In fact, more than 13 of these largest bodies could be placed side by side across the width of our planet. Even though there are millions of these objects scattered throughout the asteroid belt, the space between them is so vast that the region is mostly empty. If a spacecraft were to travel through this zone, it would most likely pass through without ever coming close enough to see an asteroid clearly without special instruments. The distances separating these objects are far greater than their actual sizes, making the belt feel more like a sparse field than a crowded cluster. Moving farther outward, we enter a region ruled by giants, beginning with Jupiter. This enormous planet stands out as the largest world in the solar system, with a diameter of about 86,881 miles. That makes it roughly 11 times wider than Earth. Its sheer size is difficult to fully grasp. If you could somehow fill Jupiter with copies of Earth, it would take about 1,321 Earths to match its volume. Jupiter also holds more mass than all the other planets combined, making it the dominant force among them. If it were hollow, every other planet could fit inside it, with space still left over. Yet even a giant like Jupiter is small compared to the Sun, which could contain about 1,000 Jupiters within its vast interior. Next comes Saturn, another massive world that is only slightly smaller than Jupiter. Saturn measures about 72,367 miles across. It is large enough to hold around 764 Earth-sized worlds within it. However, what truly makes Saturn stand out is not just its size, but its beautiful ring system. These rings are made up of countless small pieces of ice and rock, stretching tens of thousands of miles away from the planet. Despite their enormous width, they are incredibly thin. If Saturn were shrunk down to the size of a basketball, its rings would be thinner than a sheet of paper. Beyond Saturn lie the distant ice giants, Uranus and Neptune. These planets exist in the cold and dark outer reaches of the solar system. They are smaller than Jupiter and Saturn, but they are still far larger than Earth. Uranus has enough volume to contain about 63 planets the size of Earth, while Neptune could hold around 57 Earth-mass bodies within it. Because they are so far from the Sun, their journeys around it take a very long time. Neptune, for example, needs 165 Earth years to complete a single orbit. Past the orbit of Neptune lies a distant region called the Kuiper Belt. This area stretches outward for billions of miles and is filled with icy objects left behind from the formation of the solar system. Among these frozen worlds is Pluto, which was once considered the ninth planet. Pluto is only about 1,473 miles wide, making it quite small. More than 5 Plutos could fit across the diameter of Earth. The Kuiper Belt acts like a vast storage area of ancient ice, preserving materials that have existed since the solar system first formed. Even this distant region is not the true boundary of our solar system. Far beyond it lies the Oort cloud, an enormous, spherical cloud of icy objects surrounding the solar system. This region begins at a distance of about 2,000 times the distance between Earth and the Sun, and stretches outward to nearly 2 light years, reaching almost halfway to the nearest star. Objects in the Oort cloud are so far away that the Sun's gravitational pull barely holds them. They drift slowly, only loosely connected to the solar system. No one has ever seen one of these objects directly. Scientists know this region exists mainly because of comets that occasionally travel inward from this distant space, becoming visible as they approach the Sun and their icy surfaces begin to vaporize. All of this shows just how enormous the solar system truly is. It stretches across trillions of miles. Yet within this vast space, Earth is just one small rocky planet, orbiting relatively close to the Sun. If we imagine a scaled model where the Sun is the size of a basketball, Earth would be no larger than a tiny peppercorn, placed about 26 feet away. Closer to the Sun, Mercury is a small and dense world covered in craters. It has almost no atmosphere, so nothing protects it from incoming space rocks or helps to keep its temperature stable. As a result, Mercury experiences extreme temperature changes of more than 1,000 degrees, reaching about 800 degrees Fahrenheit in direct sunlight and dropping to around -290 degrees in darkness. Mercury completes one orbit around the Sun in 88 Earth days, but it spins very slowly. One full day on Mercury, from one sunrise to the next, lasts 176 Earth days, which means a single day there is longer than its entire year. Next is Venus, often called Earth's twin because of its similar size. However, the resemblance ends there. Venus has a thick atmosphere made mostly of carbon dioxide with clouds of sulfuric acid. The pressure on its surface is about 90 times greater than the pressure on Earth, similar to what you would feel deep beneath the ocean. This dense atmosphere traps heat very effectively, creating an extreme greenhouse effect. As a result, Venus maintains a constant temperature of about 900 degrees Fahrenheit across its surface, which is hot enough to melt lead. Even though it is farther from the Sun than Mercury, it is much hotter. Venus also rotates in the opposite direction compared to most planets and spins very slowly. One full day on Venus lasts 243 Earth days, and the Sun there rises in the west and sets in the east. Mars is a cold and distant world, yet it holds many features that make it fascinating to study. At its top and bottom ends, the planet has polar ice caps. These icy regions are not made of just one substance, but a mixture of frozen water and solid carbon dioxide, which is often called dry ice. As the seasons change, these caps can grow larger or shrink, slowly breathing in and out with the rhythm of the Martian year. Mars also experiences seasons, much like Earth does, with changes in temperature and sunlight across its surface. However, these seasons last much longer. This is because Mars takes a much longer time to travel around the Sun. While Earth completes its journey in 1 year, Mars takes about 687 Earth days to finish a single orbit. This means each season on Mars stretches out to nearly twice the length of those on Earth, making its winters longer and its summers slower to arrive and fade. Long ago, Mars was very different from the dry and frozen world we see today. There is strong evidence that liquid water once flowed across its surface. Scientists have discovered the remains of ancient river channels and dried-up lake beds, clearly visible in detailed images sent back by orbiting spacecraft and rovers exploring the planet. These features tell a story of a time when water moved freely, shaping the land and possibly creating conditions that could have supported life. But over time, something changed dramatically. Mars lost most of its atmosphere, the protective layer of gases that surrounds a planet. Without a thick atmosphere to hold in heat and pressure, the environment on Mars became extremely harsh. Liquid water can no longer remain stable on the surface. Instead, it either freezes into ice because of the cold or quickly turns into vapor and disappears into the thin air. Mars did not always look the way it does today. Long ago, it had a thicker atmosphere that could hold warmth and even allow liquid water to exist on its surface. But over time, that atmosphere slowly faded away. One of the main reasons for this is that Mars is smaller than Earth. Because of its smaller size, its gravity is weaker, and that makes it harder for the planet to hold on to gases in its atmosphere. However, the most important reason lies deep inside the planet itself. Earth has a strong magnetic field, created by the movement of hot, liquid iron swirling in its core. This invisible field stretches far into space and acts like a powerful shield, protecting our planet from the constant stream of charged particles flowing out from the Sun, known as the solar wind. Mars once had a similar magnetic field, but as time passed, its core cooled down and became solid. When that happened, the magnetic field faded away. Without this protective shield, the solar wind was free to strike the planet directly. Over hundreds of millions of years, this steady bombardment slowly stripped away the Martian atmosphere, leaving behind the thin, cold air we see today. Mars is also accompanied by two small moons called Phobos and Deimos. Phobos is the larger of the two, but it is still very small, measuring only about 14 miles across. It orbits extremely close to Mars, so close that it completes 3 full trips around the planet in just one Martian day. Over time, Phobos is slowly moving closer and closer to Mars. Scientists estimate that in about 50 million years, it will either crash into the planet or be torn apart by powerful tidal forces, creating a ring of debris around Mars. Beyond Mars lies a wide region of space known as the asteroid belt, located between Mars and Jupiter. This area contains millions of rocky objects, ranging from tiny fragments to much larger bodies. Even though there are so many asteroids, they are spread out over such vast distances that if you were traveling through this region, you would not see rocks everywhere like in movies. In fact, you would have to carefully aim just to come close to one. Altogether, all the asteroids combined have a total mass that is less than 4% of the mass of Earth's moon. The largest object in this region is Ceres, which is so big that its own gravity has pulled it into a round shape. Because of this, it is classified as a dwarf planet. Ceres has a diameter of about 588 miles, making it roughly as wide as the state of Texas. When NASA's Dawn spacecraft explored Ceres between the years 2015 and 2018, it discovered signs that a hidden ocean may exist beneath its surface. Some scientists believe that this underground water could contain more fresh water than all the lakes and rivers on Earth combined. Farther out in the solar system, Jupiter dominates everything around it. It is so massive that its gravity influences the paths of comets and asteroids across a huge region of space. In many ways, Jupiter acts like a giant protector, pulling in or deflecting objects that might otherwise travel toward the inner planets. Some scientists think that this role may have helped Earth avoid many large impacts, making it easier for life to develop and grow over time. One of Jupiter's most famous features is the Great Red Spot, a gigantic storm that has been raging for at least 400 years. This storm is larger than Earth itself, with winds at its edges reaching speeds of about 400 miles per hour. However, it is slowly shrinking. About 100 years ago, it was roughly 3 times wider than Earth, but now it is only about 1.3 times wider. If this shrinking continues, the storm could eventually disappear within the span of a human lifetime. Jupiter is also surrounded by a large family of moons, with at least 95 known so far, and more still being discovered. The 4 largest moons, known as the Galilean moons, are especially fascinating. Io is covered in volcanoes and is the most volcanically active world in the entire solar system, with eruptions constantly reshaping its surface. Europa has a smooth, icy crust marked by long cracks, and beneath that ice lies a vast ocean that may hold more water than all of Earth's oceans combined. Ganymede is the largest moon of all, even bigger than the planet Mercury. Callisto, on the other hand, has a heavily cratered surface that is among the oldest known in the solar system. Saturn stands out as one of the most beautiful planets because of its spectacular ring system. These rings are made up of countless pieces of ice and rock, ranging in size from tiny grains to chunks as large as houses. They stretch from about 4,300 miles to about 75,000 miles above Saturn's cloud tops. Despite their enormous width, the rings are incredibly thin, often measuring only about 30 feet in thickness. Scientists are still unsure how old these rings are. They may have formed along with Saturn about 4.6 billion years ago, or they could be much younger, possibly only a few 100 million years old, created when a moon was torn apart by the planet's gravity. Saturn also has a large number of moons, with at least 146 known so far. The largest of these is Titan, which is even bigger than Mercury. Titan is unique because it has a thick atmosphere, even denser than Earth's. The pressure at its surface is about 1.5 times greater than what we experience at sea level on Earth. Its atmosphere is mostly made of nitrogen, like Earth's, but it also contains methane. Because Titan is extremely cold, it does not have liquid water on its surface. Instead, it has lakes and seas filled with liquid methane and ethane. These substances can fall as rain, carve channels like rivers, and collect in low areas, making Titan the only place besides Earth where stable liquids exist on the surface. Another remarkable moon of Saturn is Enceladus. Although it is small, measuring only about 313 miles across, it is incredibly active. At its south pole, geysers shoot water ice hundreds of miles into space. This material comes from an ocean hidden beneath the surface. When the Cassini spacecraft flew through these plumes, it detected organic molecules, which are the basic building blocks of life. Because of this, Enceladus is considered one of the most promising places to search for life beyond Earth. Uranus is very unusual because it appears to be tipped over on its side. Its axis is tilted by about 98 degrees, which means that during its long seasons, one of its poles can point almost directly at the sun. As a result, that pole can experience continuous daylight for about 42 years, followed by 42 years of complete darkness. Scientists believe this extreme tilt may have been caused by a massive collision early in the history of the solar system, when a large object struck Uranus and knocked it over. Neptune, the most distant planet from the Sun, moves slowly along its orbit. It takes about 165 Earth years to complete a single trip around the Sun. Discovered in the year 1846, it has not yet completed even 2 full orbits since humans first observed it. Despite its great distance, Neptune is a very dynamic world, with winds reaching speeds of up to 1,200 miles per hour, the fastest in the solar system. These powerful winds create massive storms that can appear and disappear over time. For example, a large storm called the Great Dark Spot was seen in the year 1989, but by the year 1994, it had vanished and been replaced by new storms. Neptune has at least 16 known moons, and the largest of them, Triton, is especially unusual. It orbits in the opposite direction of Neptune's rotation, which suggests that it did not form with the planet, but was instead captured from a distant region known as the Kuiper Belt. Triton is slowly moving closer to Neptune, and scientists believe that in about 3.5 billion years, it will either crash into the planet or be pulled apart by tidal forces, forming a new ring system around Neptune. Far beyond the distant orbit of Neptune lies a wide and mysterious region known as the Kuiper Belt. This distant zone is filled with countless icy worlds and frozen fragments, all of them leftovers from the early days when the solar system was still forming. These objects never came together to form a full-sized planet, but instead remained scattered across this cold and dark frontier. Among all these distant objects, the most famous is Pluto. For many years, Pluto held a special place in human understanding of the solar system. From the moment it was discovered in the year 1930 by the astronomer Clyde Tombaugh, it was proudly called the 9th planet. This remained the case for many decades, until the year 2006, when astronomers carefully redefined what it truly means to be a planet. Under these new rules, Pluto no longer qualified, mainly because it had not cleared its path around the Sun of other debris. As a result, it was reclassified as a dwarf planet. Even though Pluto is small, measuring only about 1,473 miles across, it is far from simple or boring. It is a surprisingly rich and complex world. Pluto has 5 known moons, and the largest of these is Charon. Charon is so large compared to Pluto that it is about half its size. Because of this unusual balance, Pluto and Charon do not behave like a typical planet and moon. Instead, they orbit a shared point in space between them, almost like 2 partners moving together. This has led scientists to sometimes describe them as a kind of binary system. Humanity's first close look at Pluto came when the spacecraft New Horizons, launched by NASA, flew past it in the month of July in the year 2015. What it revealed completely changed how people viewed this distant world. Instead of a simple frozen rock, Pluto turned out to be a place filled with variety and activity. There are towering mountains made of solid water ice, wide plains covered in frozen nitrogen, and even a thin atmosphere that stretches much farther into space than scientists had expected. One of the most striking features on Pluto's surface is a vast, bright, heart-shaped region known as Tombaugh Regio, named in honor of Clyde Tombaugh. This feature alone made Pluto feel less like a distant point of light and more like a real world with its own identity. Pluto is not alone in the Kuiper Belt. There are other large objects out there, such as Eris, Makemake, and Haumea, all of which are also classified as dwarf planets. These discoveries have shown that the outer solar system is far more crowded and complex than people once believed. In fact, scientists think there could be thousands of such dwarf planets hidden in this region, most of them too small and too dim for current telescopes to detect. Even farther out, beyond the Kuiper Belt, lies an even more distant and mysterious region called the Oort cloud. No object in this region has ever been directly seen, but scientists are confident it exists because of the behavior of long-period comets. These are comets that take hundreds or even thousands of years to travel around the Sun. They appear to come from this faraway cloud. When a passing star moves close enough, its gravity can disturb one of these icy objects, sending it falling inward toward the Sun, where it becomes visible as a comet. The Oort cloud is incredibly vast. It begins at a distance of about 2,000 times the distance between the Earth and the Sun, and it may extend as far as 100,000 times that distance. This is nearly 2 light-years across, making it one of the largest known structures connected to our solar system. At such distances, the Sun's gravitational hold becomes very weak, and it would not take much for an object to be pulled away entirely by the gravity of another passing star. This enormous region marks the true outer edge of the solar system. Beyond it, the Sun's influence fades away, and space becomes interstellar, meaning it belongs not to any single star, but to the vast emptiness between stars. Within this immense expanse, the Earth is just a small, rocky world, about 8,000 miles across, orbiting at a distance of 1 astronomical unit from the Sun. Compared to the full size of the solar system, Earth occupies only a tiny, almost insignificant portion of space. When we move beyond the solar system and begin to look toward other stars, the distances become so large that ordinary ways of measuring no longer feel meaningful. The nearest star to our Sun is Proxima Centauri, which is part of the Alpha Centauri system. This star is about 4.24 light-years away. A single light-year is the distance that light travels in 1 year, which is roughly 5.88 trillion miles. This means Proxima Centauri is about 25 trillion miles away. To understand just how far that is, consider the distance between the Earth and the Sun, which is about 93 million miles. Proxima Centauri is roughly 268,000 times farther away than the Sun. The scale is so enormous that even imagining it becomes difficult. The spacecraft Voyager 1, launched in the year 1977, is the farthest human-made object from Earth. After traveling for more than 47 years, it has reached a distance of about 15 billion miles, moving at a speed of around 38,000 miles per hour. Even at that speed, it would take about 73,000 years for Voyager to reach Proxima Centauri, and it is not even heading in that direction. Even if humans could one day build a spacecraft capable of traveling at 1/10 the speed of light, which is far beyond anything currently possible, the journey to Proxima Centauri would still take more than 42 years. This shows just how vast the distances between stars truly are, and Proxima Centauri is only the closest neighbor. Many other stars are much farther away. For example, Sirius is about 8.6 light-years away, while Betelgeuse, a massive red giant star in the constellation Orion, is roughly 700 light-years away. Even these distances are considered relatively small on the scale of the universe. At such enormous distances, Earth becomes completely invisible. If someone was standing near Proxima Centauri and looking back toward our solar system, they would not be able to see Earth at all. Even with a powerful telescope, the Sun would appear as a bright star, but Earth would be lost in its glare, too small and too faint to detect. Proxima Centauri itself is a type of star known as a red dwarf, which is the most common kind of star in the galaxy. It is much smaller and cooler than the Sun, with a diameter of about 129,000 miles and a mass of only about 12% of the Sun's mass. Because it burns its fuel very slowly, it can continue shining for trillions of years, far longer than stars like our Sun. In fact, the universe is not yet old enough for any red dwarf star to have reached the end of its life. However, Proxima Centauri is not a calm star. It is known as a flare star. meaning it often releases sudden bursts of energy that can dramatically increase its brightness for short periods. These flares release strong radiation, which could strip away the atmospheres of nearby planets or make their surfaces hostile to life. Interestingly, Proxima Centauri has at least 2 known planets. One of them, Proxima Centauri b, orbits within the star's habitable zone, the region where conditions might allow liquid water to exist. However, because of the star's intense flares and radiation, the chances of life surviving there seem very low. Proxima Centauri is also part of a 3-star system, bound together by gravity with 2 larger stars known as Alpha Centauri A and Alpha Centauri B. Together, they form one of the most fascinating nearby systems in the galaxy. For generations, people have imagined traveling there, but with current technology, such a journey remains far beyond human reach within a single lifetime. If you keep traveling outward from the nearest stars, the distances begin to stretch in ways that are almost impossible to truly imagine. After Alpha Centauri, the next close neighbor is Barnard's star, sitting about 6 light-years away. Then there is Sirius, shining brilliantly from about 8.6 light-years away. Much farther out lies Betelgeuse, one of the most famous stars in the sky, glowing from a distance of roughly 700 light-years. This enormous star is a red supergiant, so vast that if it replaced our Sun, it would stretch far beyond the orbit of Mars, swallowing up the inner planets completely. All of these stars belong to what we might call our local stellar neighborhood. Yet even here, the distances are so huge that reaching them is far beyond anything we can realistically hope to do. When you look at Betelgeuse in the night sky, the light entering your eyes actually began its journey hundreds of years ago, back when events like the Crusades were coming to an end on Earth. Across such immense distances, our entire planet disappears completely. The whole solar system shrinks down to a tiny speck of light, and Earth itself becomes far too small and dim to ever be seen within it. Now imagine pulling back even farther. Every single star you can see with your naked eye without any telescope belongs to our home galaxy, the Milky Way. This galaxy is a vast spiral structure containing somewhere between 100 billion and 400 billion stars. Our Sun is just one ordinary member among this enormous crowd. From one side to the other, the Milky Way stretches about 100,000 light-years across. To give that some meaning, consider Proxima Centauri, which is a little over 4 light-years away. The width of our galaxy is tens of thousands of times larger than that distance. Our Sun sits about 26,000 light-years away from the center of the galaxy, in a small, quiet region known as the Orion Spur. This is a minor arm that lies roughly halfway out from the center, far from the crowded and chaotic inner regions. We are not in any special or dramatic location. Instead, we live in what could be called the suburbs of the galaxy, a calmer zone where stars are spread out and space is relatively peaceful. At this scale, the idea of Earth changes completely. Even our entire solar system becomes nothing more than a tiny dot. The Sun, which feels so enormous compared to our planet, is revealed to be just one average star among hundreds of billions. Earth itself becomes so small that it cannot even be picked out at all. If you imagined shrinking the entire Milky Way down to a structure about 100 feet across, our whole solar system would be thinner than a single human hair, and Earth would be vastly smaller still. Smaller even than an atom in that model. The Milky Way is what astronomers call a barred spiral galaxy. This means it has a long, bar-shaped region of stars at its center, with sweeping spiral arms extending outward from each end. Our Sun sits in the Orion Spur, a smaller branch that connects 2 larger arms called the Sagittarius Arm and the Perseus Arm. The galaxy is constantly rotating, but not like a solid wheel. Instead, different regions move at different speeds. Stars closer to the center orbit faster, while those farther out move more slowly. It takes our Sun about 225 million years to complete a single journey around the center of the galaxy. This immense span of time is known as a galactic year. During just one of these orbits, entire chapters of life on Earth unfold and disappear. The last time the Sun was in its current position, dinosaurs were only just beginning to appear. One orbit before that, the supercontinent Pangaea was still whole and unbroken. Over the entire history of our planet, Earth has completed only about 20 such galactic years. While the universe itself has existed for roughly 60, the Milky Way contains several different regions, each with its own character. At the center lies a dense and crowded area called the galactic bulge, packed with older stars and stretching about 10,000 light-years across. If you lived near this region, your night sky would look completely different, filled with thousands upon thousands of bright stars, making the darkness glow almost like twilight. At the very heart of this central region sits Sagittarius, a star, a supermassive black hole with a mass about 4 million times greater than that of our Sun. It is relatively quiet most of the time, but every now and then it flares to life when gas, dust, or even an unlucky star falls into it. Extending outward from the center are the spiral arms, where gas and dust are compressed and new stars are born. These regions shine brightly because they are filled with young, hot blue stars that burn quickly and die young, often lasting only a few million years. Our Sun, being older and more stable, has drifted away from the crowded arm where it was born and now resides in a quieter space between the arms. This calmer location may be one of the reasons life on Earth has had the chance to develop, since the spiral arms are far more violent, filled with supernova explosions and intense radiation. Surrounding all of this is a vast spherical region known as the galactic halo. It contains some of the oldest stars in the galaxy, along with dense clusters of stars called globular clusters. The halo stretches out to about 130,000 light-years, and beyond that lies an even larger, invisible halo made mostly of dark matter, extending perhaps as far as 600,000 light-years. Although we cannot see dark matter directly, its gravitational pull reveals that it makes up most of the galaxy's total mass. The Milky Way is not alone in space. It is surrounded by many smaller satellite galaxies, including the Large Magellanic Cloud and the Small Magellanic Cloud. These galaxies are slowly being pulled apart and absorbed by the Milky Way's gravity. Over time, large galaxies like ours grow by merging with smaller ones. Far in the future, the Milky Way itself is heading toward a dramatic encounter with the Andromeda Galaxy. In about 4.5 billion years, the two galaxies will collide and merge, forming a single massive galaxy containing around 1.5 trillion stars. Closer to home, new stars are still being born. One of the nearest stellar nurseries is the Orion Nebula, located about 1,344 light-years away. This vast cloud of gas and dust stretches about 24 light-years across and contains hundreds of newborn stars forming from collapsing clouds of hydrogen. Our own Sun was born in a similar environment about 4.6 billion years ago, along with many sibling stars that have since scattered across the galaxy. There are also groups of stars that remain bound together. The Pleiades is one such cluster, lying about 444 light-years away and containing more than 1,000 stars formed from the same cloud. Even more striking are globular clusters like Messier 13. which hold around 300,000 stars packed into a region about 145 light-years wide. Near its center, stars are so close together that the sky would blaze with light, filled with countless bright stars. From a distance of over 22,000 light-years, even powerful telescopes struggle to pick out individual stars in such a cluster. Everything blends into a dense, glowing ball. At this scale, Earth becomes not just small, but utterly beyond significance. The difference in size and distance is so extreme that ordinary comparisons begin to break down, and the true vastness of the universe becomes something we can sense, but never fully grasp. Surrounding all of this is a vast spherical region known as the galactic halo. It contains some of the oldest stars in the galaxy, along with dense clusters of stars called globular clusters. The halo stretches out to about 130,000 light-years, and beyond that lies an even larger, invisible halo made mostly of dark matter, extending perhaps as far as 600,000 light-years. Although we cannot see dark matter directly, its gravitational pull reveals that it makes up most of the galaxy's total mass. The Milky Way is not alone in space. It is surrounded by many smaller satellite galaxies, including the Large Magellanic Cloud and the Small Magellanic Cloud. These galaxies are slowly being pulled apart and absorbed by the Milky Way's gravity. Over time, large galaxies like ours grow by merging with smaller ones. Far in the future, the Milky Way itself is heading toward a dramatic encounter with the Andromeda Galaxy. In about 4.5 billion years, the two galaxies will collide and merge, forming a single massive galaxy containing around 1.5 trillion stars. Closer to home, new stars are still being born. One of the nearest stellar nurseries is the Orion Nebula, located about 1,344 light-years away. This vast cloud of gas and dust stretches about 24 light-years across and contains hundreds of newborn stars forming from collapsing clouds of hydrogen. Our own sun was born in a similar environment about 4.6 billion years ago, along with many sibling stars that have since scattered across the galaxy. There are also groups of stars that remain bound together. The Pleiades is one such cluster, lying about 444 light-years away and containing more than 1,000 stars formed from the same cloud. Even more striking are globular clusters like Messier 13, which hold around 300,000 stars packed into a region about 145 light-years wide. Near its center, stars are so close together that the sky would blaze with light, filled with countless bright stars. From a distance of over 22,000 light-years, even powerful telescopes struggle to pick out individual stars in such a cluster. Everything blends into a dense, glowing ball. At this scale, Earth becomes not just small, but utterly beyond significance. The difference in size and distance is so extreme that ordinary comparisons begin to break down, and the true vastness of the universe becomes something we can sense, but never fully grasp. Another important member of the local group is the Triangulum Galaxy, which contains about 40 billion stars and spans roughly 60,000 light-years. It is smaller than the Milky Way, but still impressive. The rest of the group is made up mostly of smaller dwarf galaxies. Among them are the Large Magellanic Cloud and the Small Magellanic Cloud, which can actually be seen from the southern hemisphere as faint, cloudy patches in the night sky. This entire local group stretches across about 10 million light-years. That may sound enormous, and it is, but it is only a small part of something much bigger. The local group is part of the vast Virgo supercluster, a gigantic structure that spans about 110 million light-years and contains at least 100 galaxy clusters and groups, holding a total of around 100 trillion stars. At the center of this supercluster lies the Virgo cluster, located about 54 million light-years away. This cluster alone contains between 1,200 and 2,000 galaxies. Some of these galaxies are enormous, even larger than our own. One of the most famous is Messier 87, often called M87. It contains about 1 trillion stars and is roughly 120,000 light-years wide. It also made history when scientists captured the first ever image of a black hole at its center in the year 2019, revealing a shadow created by a black hole with a mass about 6.5 billion times that of the Sun. If all of this still feels manageable, the scale becomes even more overwhelming. Imagine shrinking the Milky Way down to the size of a coin. In that case, the Virgo supercluster would be as large as an entire city. Everything we have talked about so far, the Sun, the planets, the distances between stars, and even the whole Milky Way, would fit onto that tiny coin. And Earth would be far smaller than anything visible under a microscope. Then, in the year 2014, astronomers discovered something even greater. They found that the Virgo supercluster is only a small part of an even larger structure called Laniakea supercluster. The name comes from the Hawaiian language and means immeasurable heaven, which is fitting for something so vast. This enormous structure contains about 100,000 galaxies spread across roughly 520 million light-years. All of these galaxies, including our own, are slowly drifting toward its center, pulled by the combined gravity of everything within it. Far out in the vastness of space lies an enormous region known as Laniakea supercluster, a truly colossal gathering of galaxies that stretches across unimaginable distances. At the very heart of this immense structure is a mysterious destination, a point toward which everything seems to be slowly drifting, almost like leaves being carried along by a gentle but unstoppable current. This hidden destination is called the Great Attractor. The Great Attractor is not just any ordinary place in space. It is a region with an incredibly powerful gravitational pull, so strong that it is quietly drawing in thousands upon thousands of galaxies, including our own. Everything within Laniakea is, in some way, moving toward it. Yet, despite its enormous influence, this mysterious region remains hidden from our direct view. From where we are inside the Milky Way, the Great Attractor lies behind the thick, crowded plain of our galaxy. Clouds of dust and gas spread across the Milky Way act like a cosmic curtain, blocking our line of sight and making it impossible to see what lies beyond with ordinary observation. For many years, astronomers were faced with a strange puzzle. They could clearly measure the effects of something massive pulling on galaxies, but they could not actually see what was causing it. It was like feeling the tug of a hidden force in the dark. Slowly, with patience and ingenuity, scientists began to look at the universe using different kinds of light that can pass through the dust. By studying radio waves, infrared light, and powerful X-rays, they started to uncover the truth. What they found was surprising. The Great Attractor is not a single object, like a star or a black hole. Instead, it is a vast region filled with several enormous clusters of galaxies, all bound together by gravity. Among these structures is the Norma cluster, one of the most massive and important parts of this hidden region. Together, these clusters form a gravitational powerhouse that influences everything around it. But the story does not end there. As scientists continued to observe the universe more carefully, they discovered something even more astonishing. It appears that Laniakea itself is being pulled by an even greater force, something far beyond the Great Attractor. This leads us to another gigantic structure known as the Shapley supercluster. This immense collection of galaxies lies about 650 million light-years away from us and contains thousands of galaxies bound together in a single region. Its total mass is almost beyond comprehension, reaching roughly 10,000 trillion times the mass of our Sun. The combined gravitational pull of the Shapley supercluster may be strong enough to influence the motion of Laniakea itself, gently but steadily pulling it, and everything within it, across the cosmic landscape. At such a vast scale, our familiar sense of importance begins to fade. The Milky Way, which feels so enormous to us, becomes just one galaxy among about 100,000 within Laniakea. And within the Milky Way, our small planet Earth becomes almost impossibly tiny. To truly grasp this scale, imagine shrinking the entire observable universe down until it is the size of Earth. In such a comparison, the Milky Way would become smaller than an atom, and Earth itself would vanish completely, becoming too small to measure in any meaningful way. Even if Laniakea alone were compressed to the size of our planet, the Milky Way would barely be as large as a single grain of sand, and Earth would slip into the strange and invisible world of quantum scales. When scientists map out where galaxies are located across the universe, they discover something beautiful and unexpected. Galaxies are not scattered randomly like grains of dust. Instead, they form long, thin threads and vast walls that stretch across space, creating a grand structure known as the cosmic web. These filaments connect clusters of galaxies like glowing strands, while in between them lie enormous empty regions called voids, where very little matter exists. This breathtaking structure did not appear by chance. It formed over an incredibly long period of time, beginning in the early universe. In those earliest moments, matter was not perfectly spread out. Some regions were just slightly denser than others, while some were a little more empty. These tiny differences, almost too small to notice, became the seeds of everything that followed. Over billions of years, gravity slowly amplified these small variations. Regions that were a bit denser began to pull in more and more matter, growing heavier and stronger. Meanwhile, less dense regions gradually lost their material, becoming emptier and emptier. As this process continued, the universe shaped itself into the vast network we see today, a cosmic web of galaxies, clusters, and immense voids, all connected in a structure that stretches across the deepest reaches of space. Across the universe, galaxies are not spread out randomly. Instead, they form enormous thread-like structures called filaments, stretching across distances so vast that they span hundreds of millions of light years. These filaments weave together into a gigantic cosmic web, surrounding immense regions of emptiness known as voids, where almost nothing exists. One such filament is Laniakea, but it is just one strand in a much larger and more intricate structure. There are many others, each forming part of this breathtaking, almost unimaginable pattern that fills the universe. Among the largest of these structures is something known as the Sloan Great Wall, discovered in the year 2003. This colossal formation is like a massive wall made of galaxies, stretching across about 1.37 billion light-years. It contains tens of thousands of galaxies, all arranged in a relatively thin, sheet-like structure. To help picture this, imagine shrinking the Milky Way down to the size of a small coin. If that were the case, the Sloan Great Wall would still stretch for miles, showing just how enormous it truly is. Even more astonishing is another structure called the Hercules Corona Borealis Great Wall, which might be the largest structure ever discovered. It stretches across about 10 billion light-years, which is roughly 73% of the radius of the observable universe. Something this vast presents a real challenge to our understanding of how the universe formed, because according to current models of cosmology, There simply should not have been enough time since the beginning of the universe for structures of this size to come together. Between these enormous walls and filaments lie the voids, regions so empty they almost defy imagination. The largest known of these is the KBC void, which spans about 2 billion light-years across. Inside this immense emptiness, there are very few galaxies. It is not completely empty, but compared to the crowded regions of filaments and clusters, it is incredibly sparse. If you could somehow find yourself floating at the center of this void and look outward in every direction, the nearest large groups of galaxies would be about 1 billion light-years away. From that viewpoint, the universe would appear shockingly empty, almost like a vast dark ocean with no visible shores. In fact, these voids make up about 80% of the total volume of the universe. This means that most of space is not filled with galaxies or stars, but with emptiness. The galaxies, clusters, and filaments, the parts we usually think of when we imagine the universe, occupy only a tiny fraction of the whole. The universe is more like an enormous ocean, with scattered islands of matter floating far apart from one another. Our own world exists on one of these tiny islands. Earth is part of a galaxy, the Milky Way, which itself is just one member of a filament within this vast cosmic web. When you look at things on this immense scale, Earth does not merely become small, it becomes almost impossible to even think about in meaningful terms. The difference in size between our planet and the structure of the universe is so extreme that the human mind struggles to truly grasp it. What we call the observable universe is the part of the universe we can, in principle, see. This limit is set by two things: the speed of light and the age of the universe. The universe is about 13.8 billion years old, which might suggest that we can see objects up to 13.8 billion light-years away in every direction. But the situation is more complicated because the universe has been expanding the entire time. Space itself has been stretching, carrying galaxies farther away as time passes. Because of this expansion, light that began its journey billions of years ago has had to travel across a constantly stretching distance. As a result, the observable universe is actually much larger than one might first expect. Its diameter is about 93 billion light-years. This is the maximum distance from which light has had enough time to reach us, once we take into account the expansion of space. Within this enormous observable region, astronomers estimate there are about 2 trillion galaxies. Each of these galaxies can contain anywhere from millions to trillions of stars. Altogether, the total number of stars in the observable universe is estimated to be around 200 billion trillion. To give a sense of how vast that number is, imagine that each star is represented by a single grain of sand. You would need several Olympic-sized swimming pools filled with sand just to match the number of stars that exist. And then there is Earth. Compared to all of this, Earth is so unbelievably small that no simple comparison can truly capture it. If you tried to scale things down so the observable universe were the size of Earth, the Milky Way would shrink to something smaller than subatomic particles, and Earth itself would become smaller than the fundamental building blocks of matter. It would effectively disappear from any meaningful scale. It is important to remember that the observable universe is only the part we can see. The actual universe is almost certainly much larger. It could be a few times bigger, or thousands of times bigger, or even infinite in size. If the universe is infinite, then even something as enormous as the observable universe becomes insignificant. Literally, 0% of infinity. Some ideas in physics go even further, suggesting that our universe might not be the only one. According to a concept called eternal inflation, the event we call the Big Bang may not have been a one-time occurrence, but something that happens over and over again, constantly creating new bubble universes. In this picture, our universe would be just one bubble in an endless cosmic foam. Other interpretations of quantum mechanics suggest something equally mind-bending, that every time a quantum event could have multiple outcomes, the universe splits into separate branches, with each possible outcome happening in its own version of reality. This would mean there could be an infinite number of parallel universes existing alongside our own. These ideas are still speculative, and we currently have no way to directly observe or test the existence of other universes. However, they arise naturally from well-established theories in physics, which is why many scientists take them seriously. If such a multiverse does exist, then even our vast observable universe, with its 93 billion light-year diameter and its trillions of galaxies, would be just one small part of something far greater. And in that context, Earth becomes not just small, but almost completely insignificant in the grandest scale of existence. Most moons and asteroids in space are much smaller than Earth. Even though Earth feels huge to us, it is actually just a medium-sized rocky world when you compare it to everything in the universe. And surprisingly, even the giant gas planets in our own solar system are small on a cosmic scale. Since the first planet outside our solar system was confirmed in the year 1992, astronomers have now discovered more than 5,500 planets orbiting other stars. Each new discovery has shown that planets can be wildly different from one another, forming systems that look nothing like our own. Some of these alien worlds are absolutely massive. There are so-called hot Jupiters, which are giant gas planets that orbit extremely close to their stars, much closer than Mercury is to our Sun. These planets can be several times more massive than Jupiter itself. For example, the planet known as HD 189733b has a mass about 13 times that of Jupiter. It is so close to its star that it completes a full orbit in only about 3 Earth days, meaning a year there is shorter than a long weekend on Earth. Other exoplanets are surprisingly small. Kepler 37b, for instance, is only about the size of Earth's moon, with a diameter of roughly 2,400 miles. Despite its tiny size, it still circles its star every 13 days. It shows that even very small worlds can survive in distant solar systems. There are also planets that sit in what scientists call the habitable zone. This is the region around a star where temperatures might allow liquid water to exist on a planet's surface. One example is Kepler 452b. It is about 60% larger than Earth and orbits its star at a distance that could potentially support Earth-like conditions. It lies about 1,800 light-years away from us. We will never travel there with current technology, but the fact that such a world exists is still astonishing. These discoveries reveal that planetary systems can be arranged in countless ways. Some stars have many planets tightly packed together in small orbits. Others have planets moving in stretched, oval-shaped paths. Some planets even circle 2 stars at once, meaning they would see 2 suns in their sky. The variety is enormous and almost endless, but the most important point is this: Earth is just one planet among thousands already discovered, and likely among billions that exist in the Milky Way galaxy alone. Earth is not rare just because it is a planet. It is not even rare as a rocky world about its size. There may be millions or even billions of Earth-sized rocky planets scattered throughout our galaxy. What may actually make Earth special as life? As far as we know today, Earth is the only place in the universe where life is confirmed to exist. Scientists continue to search for signs of life elsewhere, possibly in places like Mars, or beneath the icy oceans of moons such as Europa and Enceladus. There is also the possibility that life exists on countless other planets far beyond our solar system. But for now, Earth remains the only known living world. That makes it incredibly precious, even if it is not physically large. To understand Earth's place even better, it helps to compare it with stars. Stars vary far more in size than planets, and this comparison makes Earth seem even smaller. Our Sun is considered an average star, classified as a yellow dwarf. Its diameter is about 864,000 miles. About 109 Earths placed side by side would stretch across its width, and more than 1 million Earth-sized planets could fit inside its volume. However, many stars are even smaller than the Sun. The most common stars in the Milky Way are red dwarfs. One example is Proxima Centauri, the closest star to us, with a diameter of about 129,000 miles. That is only about 15% of the Sun's size. Roughly 8 Earths could fit across it. Even smaller still is a star known as EBLMJ 0555-57AB, with a diameter of about 68,000 miles. It is barely large enough to sustain nuclear fusion. If it were any smaller, it would not be a true star at all, but a brown dwarf, an object that never fully ignites like a normal star. On the other extreme, there are enormous stars called supergiants and hypergiants. Betelgeuse, a red supergiant in the constellation Orion, has a diameter of about 617 million miles. If it replaced our Sun, it would stretch far beyond the orbit of Mars, swallowing the inner planets entirely. But even Betelgeuse is not the largest. The giant star UY Scuti is about 1,700,000,000 miles wide, nearly 1,900 times larger than the Sun. If it replaced the Sun, its outer layers would extend beyond the orbit of Saturn. Its size is so vast that trillions of Earth-sized planets could fit inside it, a number so large it is almost impossible to imagine. When stars die, they also reveal strange and extreme forms. A star like the Sun eventually expands into a red giant and then sheds its outer layers, leaving behind a white dwarf. This remnant is about the size of Earth, with a diameter of roughly 6,200 miles. Yet it contains nearly half the mass of the Sun. That means it is unbelievably dense, about 1 million times denser than Earth. A single teaspoon of white dwarf material would weigh around 5 tons on Earth. When the most massive stars reach the end of their lives, they don't simply fade away. Instead, they explode in powerful blasts called supernovae, and what remains can be even stranger and more extreme than the star itself. One possible outcome is a neutron star. A neutron star is unbelievably dense. It is only about 12 miles wide, roughly the size of a large city, yet it packs in between 1.4 and 2 times the mass of our Sun. That means something incredibly strange happens to matter inside it. Everything is crushed so tightly that a single teaspoon of neutron star material would weigh around 4 billion tons. But some stars are even more massive, and their fate is even more dramatic. Instead of becoming neutron stars, they collapse completely into black holes. A black hole is a region in space where gravity is so strong that absolutely nothing can escape it. Not even light itself. It is as if space has been bent into a point of no return. At the center of our own galaxy, the Milky Way, there is a supermassive black hole called Sagittarius A star. It contains about 4 million times the mass of the Sun. Yet, surprisingly, its event horizon, the boundary beyond which nothing can escape, is only about 17 times wider than the Sun itself. This makes it incredibly compact for something so massive. Even more extreme is the black hole in the galaxy M87, which was famously imaged in the year 2019. This giant has a mass about 6.5 billion times that of the Sun. Its event horizon stretches across about 23.6 billion miles, which is roughly 250 times the distance between the Earth and the Sun. Even so, it is still tiny compared to the vast galaxy that surrounds it. These exotic objects reveal something very important. In the universe, size and mass do not always match in the way we expect. A white dwarf star can be smaller than Earth, but still contain more mass than the Sun. A neutron star can be no larger than a city, yet outweigh our Sun. These are objects so dense that nothing on Earth can truly compare. When we zoom out even further, we begin to see galaxies, which are enormous collections of stars, gas, and dust. These galaxies come in many different sizes, and the differences between them are extreme. The most common type is the dwarf galaxy. These contain anywhere from a few million to a few billion stars and are usually only a few thousand light years wide. The Large Magellanic Cloud, which orbits our Milky Way, has around 10 billion stars and spans about 14,000 light years. Its smaller companion, the Small Magellanic Cloud, is even more compact. At the very smallest end are ultra-faint dwarf galaxies. One example, called Segway 1, contains only about 1,000 stars and stretches just a few hundred light years across. It is so small that it barely qualifies as a galaxy at all, and often resembles a large star cluster instead. These small galaxies are extremely common. Large galaxies like the Milky Way are surrounded by dozens, sometimes hundreds, of these tiny companions. The Milky Way itself has about 50 known satellite galaxies, while Andromeda has a similar number. These small galaxies are thought to be ancient leftovers from the early universe, the basic building blocks from which larger galaxies formed as they merged over time. On the opposite extreme are giant elliptical galaxies. One example is IC10-1, which stretches about 6 million light-years across, around 60 times larger than the Milky Way, and contains roughly 100 trillion stars. It grew over billions of years by absorbing other galaxies, slowly becoming a cosmic giant. Another example is galaxy M87. Although it is similar in width to the Milky Way at about 120,000 light-years across, it is far more massive and contains around 1 trillion stars. At its center lies a supermassive black hole weighing about 6.5 billion times the mass of the Sun. These enormous galaxies are rare. In fact, most galaxies in the universe are small dwarf galaxies. The Milky Way, with its vast structure and hundreds of billions of stars, is actually in the top 5% of galaxies by size. Around 95% of galaxies are smaller than it. Yet even the Milky Way is just one piece in a far larger cosmic structure. Galaxies are grouped into clusters. Clusters form superclusters, and all of them are connected in vast filaments known as the cosmic web. At those scales, even the largest galaxies become tiny dots in a much greater pattern. And compared to all of that, Earth almost disappears completely. The Milky Way is about 100,000 light-years wide, while Earth is only about 8,000 miles across. The difference is so enormous that Earth becomes effectively invisible on galactic scales. To understand scale even more deeply, we can zoom into what everything is made of. Atoms. Atoms are incredibly small. A single hydrogen atom, the simplest type, is about 0.1 nanometers wide. That is 1/10 of a billionth of a meter. You could line up about 10 million atoms across the width of a human hair. Now consider Earth itself. Its mass is about 6 trillion kilograms. Most of this is made of elements like iron, oxygen, silicon, and magnesium. When you break it down to the atomic level, Earth contains roughly 1.3 times 10 to the power of 50 atoms. That is a number so large it has one followed by 49 zeros. If you counted one atom every second, it would take far longer than the current age of the universe just to finish counting Earth alone.